Steady!
Stand! Welcome. I'm here to talk to you about dragons. See here? Dragons, well, they're creatures of fairy tales, but for many thousands of years humans thought they were real. And we have proof too. If you go to any cave around the region, you'll find bone beds like this. Caves just full of dead animals. There's two bones that anyone can recognize. First, you've got that skull. Massive, strong jaws, sharp teeth. That could be nothing but the skull of a dragon. And then, you'll also see long bones, leg bones, and their favorite food, the unicorn. People knew this, especially in the medieval days. And being humans, what did we do with them? We ate them. Unicorn bone tea was known as a cure-all for any disease, and dragon skull tea was, well, it was the medieval Viagra. This went on as a great business of selling bone tea for millennia, until science came along and ruined everything. See, it turns out, dragons aren't real. They're bears. And when you look at the evidence, it makes a little sense. Yeah, there's a big skull. Oh, kind of looks like a bear skull, right? And as it turns out, bears also have legs, so it's problem too. But there was another problem. We now knew that they weren't dragons, but science also said unicorns weren't real. So what did they eat? Well, there's an easy way to look at this. They had jaws. Big jaws. Strong jaws. Sharp teeth. Massive muscle scars. You look at that skull, the only thing it can ever remind you of is hands. Because, and let's do a little science next time you eat. Sit down to a steak dinner, but then also put a little piece of wood on that plate. You'll notice it takes a lot more chewing to get through that wood than it does through the steak. So plant eaters like pandas tend to have some of the strongest jaws. However, there are other animals with strong jaws, like hyenas. So that's not evidence that they ate plants. It's just maybe a wink and a suggestion. Of course, modern scientists tried to solve this using isotopes. The way this works is that isotopes become heavier as you go up the food chain. So plants have light isotopes, herbivores have medium, carnivores have heavy. Well, people did this with cave bears. And it's easy. On the top, you've got the carnivore, the panther. In the middle, you've got all the herbivores. And on the bottom, you've got, wait a minute, bottom you've got bears. Well, this was a fine theory. It was thought for a while that maybe there was something weird going on. That's probably not right, so we decided for my project to do something different. I decided to look at teeth as the mad tooth fairy of science. I'm very sorry. Don't worry, I'll have another tube of glitter. A lot of chance. So, let's say, look at that handsome man in the middle. Let's say you want to know what he ate. Well, there's lots of parts of his teeth you can look at to find out. First one, you can just look for damage, cavities and such. They'll also tell you if he was eating something weird that he shouldn't. For example, humans like to eat lots of sugar. But then also, we eat a lot of wheat, which we didn't evolve to eat. So, when you get down to it, that'll also give you cavities, even if you don't eat chocolate. Additionally, sometimes you'll see patterns like that, which looks really crappy, because that's really small. Let's get a more expensive SEM photo. There we go. Remember, science is pay to win. What you see here is the enamel crystals from a tooth that have been etched by acid Usually in nature, that means that they were eating lots of fruits, lots of berries. Maybe this guy liked fruit salad. Or perhaps a PhD student fruit salad. Which reminds us, an apple a day keeps the doctor away, but it doesn't do crap for the dentist. So, anything rots your teeth, you might as well have some candy. They're gummy bears, too. So, I mean, it's even appropriate. Think of them as a cure to gullibility in unscientific studies. But, finally, you can look at dental microwear, which is a fine pattern of scratches and dents in the teeth left by a diet. And this one, let's say that's a picture of his tooth. You might compare it to a bunch of other teeth from creatures whose diets you know and control. And then, that looks like an otter tooth. I bet he was eating fish. So, that was what I decided to do. Took my cave bear skull. But in order to look at it that small, you have to gold coat the teeth. And unfortunately, when I said, let's start coating ancient teeth in gold, people were like, no. So, instead I had to mold them, make a cast of the mold, that nice gangster grill, then put it under a scanning electron microscope, hit it with a beam of lightning, bam! There you go. An actual cave bear tooth microwear. Lots of scratches, lots of pits, lots of artifacts. You want to do it with the SEM. So, here's what we do with them. You tally up all the scratches and pits. You also tally up other data, like how big they were, and sometimes people use orientation and such. And then you plot everything against everything. Now you're thinking, how can you plot in 6 dimensions? I can't, I go mad. Thankfully my computer doesn't. So my computer plots in 6 dimensions, and then it will select the 2 dimensions that it thinks are best. This is called a principal component analysis. So let's have a drum roll. Let's get that ready. Show the results. Come on, guys. Okay, we're going. Look, those are the diets are in clusters. The insectivores clustered. Come on. Drum roll. Kind of are close to one of the bone eaters, so definitely whatever they were eating was hard, but they don't cluster with both bone eaters, nor do they fall in the space between, so probably they weren't eating bones. In other words, I found out nothing! Now, I did a few other things. There, you can see there's different locations with bears. I did this in the vain hope that maybe one of the locations had a different diet that would cluster. It didn't, but hey. So what do you do when that happens? Well, you go through the 5 stages of tree. And then, if you're really, really lucky, someone tells you that you can present your research in a tutu.